Students, today we will learn ring counters and Johnson counters. First of all, we will study how do they work and what pattern of counting they produce, and then later on we will see where they can be used, means area of application. So first let us focus on the circuit of a ring counter. Observe it very carefully. We are having 3 D flip-flops. D flip-flop is a very simple flip-flop which has only one input, and that single input decides what it will be storing. So if you provide 0 at this terminal, it will store 0, and if you provide 1 at this terminal, it will store 1. This is the simple application of a D flip-flop. All of these 3 flip-flops will behave in the same manner, and above all of them are negative edge triggered. You can see from this symbol, this is for negative and this is for edge triggering. So all of them will be waiting for a negative edge in this clock pulse. So common clock pulse is feeding all the 3 flip-flops. That means it is a synchronous device. And in addition to that, we have first flip-flop connected to preset. Preset means if we provide signal at this port, it will be preset to 1. And similarly, this clear terminal indicates that when signal is provided here, high signal is provided here, it will be cleared to 0. So these 2 flip-flops are in are connected their clear port, and this is connected with its preset mode. So this signal bar means when a 0 will be provided, this will be activated. So a 0 provided at this terminal will first of all preset first flip-flop, clear second flip-flop, clear third flip-flop. So now let us see with the pulse diagram how do they work. Flip-flops are named as A, B and C as usual. So similarly corresponding ports DA, QA etc. are connected like this. So connection is made in cascading. So first flip-flop is provided the output of third flip-flop QC. Second flip-flop is connected to QA, and the DC input port of third flip-flop is connected to QB like this, right? So signal will travel in this direction, so information will travel in this circular path. So first of all, when we start its functioning, we will provide a clear signal. This clear signal, this is the clock pulse. As you see, we are having 3 clock cycles and every negative edge will be effective. So therefore we have marked with it with the dotted lines. So first of all, clear signal is provided to all the flip-flops. So this clear signal will preset this flip-flop to 1, and this flip-flop will be cleared to 0, and similarly this will be cleared to 0 like this. So this is the initial stage 1 0 0. First flip-flop contains 1, second contains 0, and the third one contains 0. When the next negative edge reaches, at this negative edge, let's consider what will be the inputs to this port. This flip-flop is getting this input, means 0. This flip-flop is getting this input 1. This is getting this input 0. So when a negative edge reaches, it will be reset to 0, it will be set to 1, and it will be reset to 0. Hope you understand. So after first clock cycle, first negative edge, this flip-flop will be 0, this will be 1, and this will be 0 like this. Okay, now let's wait for the second negative edge. Before that, let's work out what are the inputs to the D flip-flops. This flip-flop has input 0. So first flip-flop will be, whenever there is a negative edge, it will be 0 as such. this flip-flop has 0 input now. So whenever there is a negative edge, it will be reset to 0. And similarly, third flip-flop has input 1. So whenever there is a negative edge, it will be preset to 1. So at the next negative edge, situation will be like this. So this will be 0, this will be 0, and this will be 1. So now the current state will be like this, 0, 0, 1. Okay, on the next negative edge, what will happen? This 1 will travel to the first flip-flop. So this will become 1 from 0. And this 0 will travel to the second flip-flop. So it will be 0 as earlier it was. And the third flip-flop also has 0 input. So it will be 0 from 1. So the next negative edge will make it 1, make it 0, and will make it 0. So at the next negative edge, this will be the status. So this will be the counting. This is how a ring counter works. So you can clearly see that there is only one high signal in the stream, and it keeps on changing from left to right and then to right. And after, first it was on the this bit position, and then it was on the this, and then it is on the third one, and after that it will be again shift to first position. So if you have more counters, for example, you have 8 flip-flops, you are using 8 flip-flops, 1, 2, 3, 4, and they are connected in such a way the output will be 8-bit output, and this position of 1 will be shifting towards right, and after reaching on the rightmost position, it will be on the leftmost. So this position, this high signal will be shifted towards right as the clock cycle changes. So this can be used in so many algorithms. For example, ring algorithm token, in which networking is done in such a way that it is turn off one PC, then the second PC, then the third PC, and so on. More clear details can be have in the networking lectures. Now let's move on to the other counter, which is Johnson counter. Johnson counter, look at the circuit. We are using 3 JK flip-flops. All of them are negative edge triggered. So they are named as A, B, and C, etc. So first flip-flop has its inputs from the last one, but there is a change. JA is not provided QC, rather it is provided QC complement. So QC complement is fed to this terminal JA. Similarly, KA is provided QC. And after that, QA is provided straight to JB, QA complement is provided straight to KB, and similarly QB to JC, QB complement to KC. So this way we have a shift of data from first flip-flop to second to third, and after crisscrossing, third output will be fed to the first one. All of them are having same common clock pulse, so it will be a synchronous device and a clear signal. This time we are providing this signal to the clear terminals only. Means when we provide a signal at this port, all of them will be cleared to 0. Let's study how pulse moves. So in the beginning, when a clear signal will be provided, all the flip-flops will be reset to 0. QA will be 0, QB will be 0, and QC will be 0. So all of them are having zeros. So this is the first state which it counts, 0, 0, 0. Right? Now on reaching first negative edge like this, on reaching here, what is the inputs to the flip-flops, all the flip-flops? First flip-flop, look at this first flip-flop A, it contains JA it ekes it out from QC complement. So QC is 0 and QC complement will be 1. So this 1 will be fed at JA and this 0 will be fed at KA. So this flip-flop has input 1 at JA, 0 at KA. If you remember, JK flip-flops on receiving this combination of input JA1, KA0 will be set to 1. So on reaching first negative edge, this flip-flop is ready to be set from 0 to 1. So now let's focus on to the inputs of the second flip-flop. JB 0 and KB is QA complement, which should be 1. So J input of this flip-flop is 0, K is 1, means this flip-flop will be reset. And similarly this flip-flop has 0 input at J terminal and 0, this is 0, this is 1, and this 1 will be fed to the K terminal. So this flip-flop is also in 0 and 1 combination of input. So this combination keeps the flip-flop reset to 0. So this flip-flop is ready to be set and this is ready to be reset again, and this again will be ready to be reset. So now on reaching first negative edge, this will be the status. First flip-flop will be set and the rest of two will be reset. So this will be the output. So now what is the current input now? So this flip-flop has this is 0, this is 1. So 1 will be fed here. This is 0, 0 will be fed here. So 1 0 means again this is ready to be set. And about this flip-flop, it has 1 on first J input and 0 on K input. So 1 on J, 0 on K will be resetting this flip-flop on the next negative edge. Setting this flip-flop to 1. So similarly this flip-flop has 0 and 1 combination, so it will remain reset. So on the next negative edge, this flip-flop will be set, this will be set, and this will be reset. So 1 1 0 like this should be the next state. So the next state is 1 1 0. Right? So on the next negative edge it is 1, this has also become 1, but this C is 0. So now on the next negative edge, again this flip-flop first flip-flop A has 1 at JA and 0 at KA. So it will remain in the set state. Similarly this flip-flop has 1 at JB and 0 at KB, so it will also be set. And the third flip-flop Q, 1 will be fed to JC and 0 will be fed to KC. So JC 1, KC 0 means this will be ready to set. So on the next negative edge it will also be set. So all the flip-flops are now in 1 1 1 position. So now next see what happens on the next negative edge. First input of the A flip-flop, this is 1, this is 0. So 0 will be fed at JA and this 1 will be fed at KA. So 0 1 combination for this flip-flop will be trying to reset it. And similarly second flip-flop B is having 1 and 0 combination, so it will remain in set position. Similarly third JC is high 1, KC is low 0. So 1 0 combination will keep it in the set position. So on the next negative edge, what is expected? This will be reset. First flip-flop will be reset, second will be set, and third will be set like this. Similarly on the third on the next negative edge, this flip-flop A flip-flop will have 0 at its JA terminal, 1 at its KA terminal. Means at the next negative edge it will be trying to keep reset. This flip-flop has now 0 on JB and 1 on KB. So 0-1 combination will reset it. So it will change from 1 to 0. And this flip-flop is having 1 and 0 combination, so it will remain as such 1. So on the next negative edge, this flip-flop should remain reset 0. This should also reset 0. This should remain in the set position 1. So at the next negative edge, this will be the situation 0, 0, 1. So this type of state will be achieved. And after this, on the next negative edge, you can see this flip-flop has 0 at JA, 1 at KA. So it is again be ready to reset. This flip-flop will also be in a position to be reset. Now this flip-flop also gets a position 0 input at JC and 1 input at KC. So it will also be reset to 0. So at next negative edge, this will be the state 0, 0, 0, right? So now look at this pattern. It had earlier 0, first flip-flop became 1, after that second also became 1, after the third also became 1. So now on afterwards, first became 0, the next on the next negative edge, second also became 0, on the next negative edge, all of them became 0. So this is the cycle of states which it will transit to. So this is the functioning of Johnson flip-flop.